Hey guys, welcome to our presentation of the AI second project. We are the team Don't Stop. In this video, we will first introduce our strategies and the techniques that have been tried and implemented, followed by the final design decision made, challenges experienced and possible improvements. Finally, the demo of the different agents will be provided. We've considered two different types of strategy. The first one is having both agents offensive, eating the food in the opponent area. The second one is having one agent defense and the other attack. We finally decide to use the double offensive agent because it often beats the agent with offensive and defensive strategy in our experiments, and similarly, it is difficult for a single defender to chase two attackers. Actually, we've tried many techniques. One of the techniques, the multicolor tree search, was abandoned due to its inefficiency, and the rest were integrated into our final agent. Our team used approximate Q-learning to make the main attack strategy. For this method, the Q value can be obtained by selecting appropriate features for linear calculation without storing complete Q table. A lot of features have been extracted for better tracking the food and avoiding being caught by the opponent. The reward is calculated as mentioned on the slide. For each step, the action with the highest Q value is chosen as the next action. The final weights of our agent are trained 100 times and has been adjusted manually. The approximate Q-learning is effective and guarantees convergence. It can be easily integrated into the offensive agent with other techniques with learning. However, it is difficult to determine a good reward to improve learning efficiency. The heuristic search technique was applied in both defensive agent and offensive agent. The defensive agent finds effective route to its enemies with the help of this technique. For offensive agent, weighted A star was used for finding way home. Instead of choosing action for every step, weighted A star method allowed to define the whole path before start moving. The benefit of using this method is that it could guarantee the path found is optimal, but this could lead to the less flexibility of the agent. The Monte Carlo tree search was used to build a complete agent. The reward is the customized features with different weights. Each node of the tree represents a game state after an agent playing one action. The steps are shown in the figure, and the process in detail is written in Wiki. This method was not adopted finally due to its poor performance and difficulty in optimization of the reward parameter, but we will still demonstrate it in the demo. The offensive agent used goal recognition. It identifies the intent of the other party and executes the targeting strategy. Here, we use functions that produce bitmaps to determine its goal, whether it is traced, trapped, or chased based on the input X and Y. Then the agent will adopt different policy based on its current situation. The first challenge we experienced is the scatter in search of food. Two Pac-Mans find similar way, which led to inefficient attacks, since they both implement heuristic search. The second is that some teams will keep Pac-Man in a corner and not kill it so that our Pac-Man will be trapped. In this case, the agent's partner will eat the capture to rescue the agent. When there is enemy around the middle line on the way home, it is easy to get stuck. As a countermeasure, we use the A-star search algorithm to avoid the opponent and find a new way home. The future improvement can be considered in three ways: strategy, algorithm, and performance. As for strategy, the agent better make attack and defense conversion at the right time. The abandoned Monte Carlo tree search needs to be optimized by some progressive pruning strategies. It can also be used for goal recognition in the future enhancement. Moreover, the agents need more feature to tackle complex problems. So here comes the demo. Our blue Pac-Man will head to the capture when being chased. In this demo, our red Pac-Man avoids walking into the corner, given the green ghost is nearby. In this case, our orange Pac-Man can avoid the ghost and find a new way home. As for the live demo 4, when the red Pac-Man was trapped in a corner by the green ghost, the orange Pac-Man will head to the capture to save the red one. This demo shows the pitfalls of our offensive agent. The orange Pac-Man was so greedy that it ran into the corner for food and eventually got caught by the green ghost. This demo shows the defensive agent. The orange Pac-Man managed to defend the food by driving the blue Pac-Man into the corner and caught it. When fighting against the baseline team, our multicolor tree search acts as if the action is selected randomly because we set the budget and depth very low for less time spent. Otherwise, it will run out of time for each step. Thus, we didn't adopt this technique.